Hi and welcome back. In this video we are going to have a look and see how the open source wireless access point they work, but since we don't have an open source wireless access point, we will use just the normal consumer grade wireless access point, and we will see how we can convert this access point to an open source access point. We will see how we can load OpenWRT, which is an open source operating system for wireless access point, onto this kind of wireless access point. So first of all, let's have a look at inside of this wireless access point and see what are the components, how they operate. All right, so here we got the TP-Link opened up. Now, as you can see, the design of this wireless access point is very simple. In general, the design of most of the wireless access points are very simple because they are based on the system on a chips chipsets off the shelf coming from the silicon vendors. So in this case, we got a Qualcomm. This should be a QCA9533, which is it's a 300 megabit per second 802.11n. Wireless chipset. So this single chipset, it includes the wireless subsystem, includes 5 Ethernet ports, and also includes all the functions that it requires to operate the wireless, like the software within this SoC built into the hardware for creating wireless SSIDs, doing WPA, WPA2 encryption, doing the NATing on the WAN port, doing the firewalling and all this stuff. Everything is built into this single chip which we have here. Now, to support this chip, the RAM is external. Also here there is a horizontal DDR memory here, and we got the small little 32 megabit flash memory also here, which is functions for storing the firmware for this system on chip, for this SoC. So the firmware which is already here is from the manufacturer. So in this case is the TP-Link firmware. And so in this demo today, we will change this firmware and we will load OpenWRT inside this flash, and we make this SoC to work with OpenWRT for our purpose, to see how we can make this wireless access point as a disaggregated wireless access point. Disaggregation here means that we can change the software. So although this is a bundle of the software and hardware, but we can change the software within this wireless access point. There are other open source wireless access points which are mostly coming from H-core networks. So those access points are coming again with similar kind of architecture, with similar chipsets, either from Qualcomm or from Broadcom, or even the other chipset companies like MediaTek, or So let's have a look at how we can load the OpenWRT inside this wireless access point. All right, so now we have connected the PC to that wireless access point. I have powered it up. And this access point is using the IP address 192.168.1, and we will just log into this access point, username admin and password admin, the default username and password. And here we go. So this is the manufacturer's original factory firmware on this access point. So we are going to change this firmware and change it to OpenWRT. So to do this, I just need to take this firmware version, the hardware version, the product name and the hardware version, which is the version 9, and this one. And I searched it already inside openwrt.org. If you search the model of the access point, if it is supported, give you a complete page about how to load and unload OpenWRT. For this particular access point. So here we got the TP-Link WR841, which is the access point which we have here. It says the information is 2 antennas, 4 port and 1 port, so total 5 Ethernet ports, 10 fast Ethernet ports, 4 megabyte or 32 megabits of flash, 32 megabyte of RAM is there, and also the information about the different versions. different hardware versions. So this model has started from 2007 and it continues. And now, for example, the version which we have is version 9, which is a 2014 version, and the new versions, like version 13 here, it says that there is a major hardware change in the version 13 of the same access point. Now they are using the MediaTek SoCs, system on chips, instead of Qualcomm. So same manufacturer, they use different chipsets based on the availability in the market, and also when some new chipset or silicon manufacturers, they produce something new, they may change the chipset. This table shows some information about the hardware. So for example, here we got the version 9, we are running on the Qualcomm 9533. The previous version, they were all based on Atheros. This one also, I think it's just the same Atheros, because Atheros got acquired by Qualcomm. The flash memory chipset, and also the the RAM is also specified. The RAM, actually, the one I saw, it's a Zentel, not the Winbaum, so it might be different in different versions or different production lines. We got some more information about the CPU and port indexes. Now this table is interesting because it gives us the installation URL. That's so based on the version number of the hardware, we can download the correct file, the OpenWRT file, which we are going to install on this access point. So this one is the OpenWRT install image, and this one is the upgrade image. We don't use the upgrade image because currently we don't have any OpenWRT on this access point, so I will download the OpenWRT install image for version number 9, which we got. So let's click here and download this file. Now for installation of this this firmware, it's simple. It just says you can do it through the web interface. First download the image and log into the web interface of the access point, and you can just do the firmware upgrade from the web interface. So that's very sweet and easy for doing that. And let's try and do the upgrade. So I will go back here on our wireless access point. I go to System Tools, Firmware Upgrade, and I choose the new file which was downloaded. This one, this is the OpenWRT. This is the file just downloaded now. And we click on Upgrade. Are you sure you want to upgrade? Okay, yes. So I choose to upgrade, and let's give it some time. Let it get completely flashed, and we will continue after that. Alright, so the access point rebooted, and the IP address has actually got changed. So in between I was changing the IP address of this machine. So the access point now is 192.1.1. Previously it was 0.1. So now we got the web interface of the OpenWRT of the same access point. I just need to set a password for the first time, and same thing here. We can enable the SSH access, which is important, for our testing and development works, on the access point. Dropbeer is a piece of software which is very similar to OpenSSH, but Dropbeer is very lightweight version of the implementation of the SSH server on, which is created for very low end machines with very low CPU and memory. So that's why we have Dropbeer here. So Dropbeer, you can define it should listen on which interface for the SSH port. Password authentication, we can enable or disable the password authentication, disable the root login, and also you can disable the SSH from root. So I just configured the IP address, the root password. If you go to the status, it just shows the information of the OpenWRT, the system, the free memory, the DHCP, all the stuff. And also you can do you can check also the system software, the packages. So OpenWRT is a modular system. It uses OPKG for installation of packages. It's very similar to other Linux package managers, and you can install from range of the packages which are available from OpenWRT. If you click on the install packages, for example, here we got BusyBox is installed, we got DNS Mask, which I think is used for the DHCP, we got Dropbeer Firewall and IP tables and other different components which has been listed here. Now let's try to do the SSH to our OpenWRT. Let's get this terminal, and if I do SSH root at 192.168.1.1. Okay, I have this in another machine. Let me fix this. Okay, so now we got that fixed. And we just enter the password, and here we go. We are in the shell of the OpenWRT on this wireless access point. So as I said, we have OPKG commands which we can call. So it's similar to other package managers like Yum or apps of Ubuntu, but here we don't have internet access on this wireless access point, so it's not able to connect to the OpenWRT and get the list of the available packages. So on the SSH, you have full access. In general, you can do lots of stuff from here, and as you can see here, also the file systems, the different partitions that has been already created. All right, so this was the process for actually hacking a wireless standard consumer grade wireless access point and changing into OpenWRT. But there are open source, open hardware wireless access point available for enterprise grade, kind of access point, which are available. If you go to opencompute.org, from OpenCompute, and we go to projects, networking project, we can click on specification and designs. So here in the OpenCompute project, these are all the list of the hardware, the Ethernet switches, as well as wireless access point, which are all the design has been submitted for OpenCompute. Some of them are accepted hardware, they are already certified, and some of them are still under review, or they are not yet certified. So here most of the stuff here are the Ethernet switches, for example the Facebook switches, the Wedge 32 port 100 gig switches, or the 400 gigabit per second switches from H-Core. These are all available here, the full design and the specification. Now there are wireless access points also here. So for example, there are a few of them here. So let's have a look at this one, the ECW5410, which is a 802.11ac 4x4 indoor wireless access point. So for each of these products which are listed in OpenCompute, we can download the design specification, which is the open spec for the hardware, which can help us to understand how the product works. So this one is an enterprise grade access point, open source access point, and it is based on Qualcomm processor. So it has a Qualcomm CPU 8068, and it got two separate radios also from Qualcomm, 9994 so the same chipset has been used for one chip dedicated for the 5 GHz and one chip dedicated for the 2.4 GHz radio. Separate chips for the RAM and flash are all available here. These are all the the designs of the wireless access point. We can see it's got 2 Ethernet ports, which once we load the open source Linux software here, we can create a bonding or ether channel, link, aggregate these 2 interfaces to become one single higher throughput interface. Is the block diagram of this access point. So everything is connected to that main CPU here. And the 2 radios we got another optional Bluetooth chipset also, which is controlled again by the same CPU here. The 2 interfaces, we got 2 PHYs, and also we got the PCB layouts showing here. In some of the designs, if you look, you will be able to find the complete schematics, the Gerber files, and also the PCB layout of those products in the Open Compute. So these are the real open hardware, open source wireless access point. There are a few of them there, and so these are they just come with the ability to for you to load your own choice of the operating system on this wireless access points. It's not coming. It's not similar to what we did just now with that TP-Link. Alright, so now you may think about that, why do we need open source wireless access point, why it is required, and what problem is it going to solve. So in general, all the wireless access points, especially the enterprise grade wireless access point, they are all coming with a closed function. So they are all managed through a central wireless controller. So with open source wireless access point, you can deploy your own version of the CAPWAP agents on those wireless access points. So CAPWAP is a protocol which is used between wireless controller and wireless access points. It's a standard, open standard protocol from IETF, and you can and the CAPWAP agent also is available, is open source. So you can, there are open CAPWAPs available, project available for OpenWRT, which includes all the details for building these agents for OpenWRT, and you can put it on these access points. Whatever access point you are using, you can just compile and use the CAPWAP agents on your OpenWRT. And you can also connect it to, if you got a CAPWAP server access controller, you can use that to manage all of your wireless access point who are running the CAPWAP. So through CAPWAP, you can manage the wireless access points for creating SSIDs, managing the WPA or WPA2 keys, making the authentication happen through a central radio server, or some other central PAM servers. You can create also automated deployment and management. You can integrate your wireless system with with any other subsystem. You can create a portal for creating guest wireless network, for example, and based on the time, that specific SSID with some specific password, it can show up, and there are lots of cool stuff which can be done. Another important thing is, with this open source wireless access point, you can create you can integrate it to your SDN network. You can create a software defined wireless network. So the CAPWAP, for example, is supported by SDN controllers like Open Daylight. So CAPWAP is one of the southbound protocols supported by Open Daylight, and Open Daylight will be able to manage your wireless access point who are all communicating to ODL via the CAPWAP. So that's also another cool stuff which you can manage and control thousands of access points using your SDN controller. In terms of customization, you can once you have a wireless access point where you are free to do anything with it. You can download, package anything available from the OpenWRT, and also you can compile and install something else. The build chains are all available for different processors. So the processor we had here was I think it's a MIPS processor. So you got the tool chain for MIPS. You can compile some other code, and you can run it on the OpenWRT on your TP-Link wireless access point or anything, or the Edge core access point. You can do also, from security wise, there are lots of things can be done. The simplest one is to, doing the honeypot projects. So honeypots, there are some commercial versions, of coming in the market right now, but creating cool honeypots, or doing combining the honeypot with wireless intrusion prevention system or wireless intrusion detection system. That's also some other cool stuff which can be done using this open source wireless access points. So this was about disaggregated wireless. If you have any question, please feel free. You can write it in the forum, or you can contact me directly. Thank you very much.